Hello everyone, welcome to the TechnoTrek channel. Today we're going to take a look at an LC meter project that will become one of the most important tools in our electronics laboratory, featuring high precision and automatic range selection. You'll see how we designed this device from start to finish, delivering outstanding accuracy in both inductance and capacitance measurements. Unlike classic LC meters, this project automatically adjusts the measurement range based on the value of the component being measured. One of the most important points is this. For this project, you don't need industrial equipment or expensive measurement instruments. All the design, assembly, and testing processes were carried out at home using easily accessible components. The term high precision here is not just a bold claim. Thanks to the measurement algorithm, reference frequency structure, and calibration approach, this device delivers accuracy well beyond typical hobby projects. If you want to build your own measurement instrument, gain a deep understanding of electronic measurement principles, and create a project that truly works, this video is just for you. When designing a high-precision LC meter, one of the most critical factors is the quality of the reference inductors and capacitors used. In this project, we selected reference components with low tolerance and minimal variation with temperature. The display used in this project is configured to present measurement values in a clear and easy-to-read format. During measurement, the device largely detects which type of component is connected automatically. When required, the active measurement mode can be clearly monitored on the display. This way, the user can easily see whether the measurement is inductance or capacitance without any confusion. Once the hardware is ready, the next step is loading the firmware that truly brings the LC meter to life. This software controls the entire process, from measurement timing to frequency calculations and auto-ranging decisions. The software evaluates measurement reliability and, if necessary, switches the measurement circuit to a different reference range. Now, we're making the final adjustments before mounting the LCD screen onto the board. After uploading the firmware to the Arduino Nano, we connect the LCD and run the tests. The message appeared on the LCD screen exactly as we wanted, and the firmware we uploaded to the Arduino Nano is working perfectly. Now, we can start placing the other important components onto the board. Now we can plug in the LCD. Just make sure the pins are lined up and that it's firmly in place on the board. We're screwing in the LCD from the back to make sure everything stays perfectly aligned and securely in place. At this point, we'll take the Arduino Nano we just programmed and carefully slide it into the socket on the board. I'd like to thank the sponsor of this video, NextPCB. NextPCB stands out as a reliable partner in the industry, delivering high-quality PCB solutions for any project. Whether you're a hobbyist or a professional, you can order this project's PCB from NextPCB using the Gerber files linked in the description. Simply choose your quantity and color, and you're good to go. Whether you're working on hobby projects or developing professional designs, working with NextPCB saves you both time and provides a significant cost advantage. You can choose NextPCB for your own projects with complete peace of mind. We've successfully finished assembling the LC meter board. Now, it's time to move on to testing and verification. For the first step of the testing process, let's check the measurement performance of the LC meter by using capacitors of different values. In this part of the testing process, we're evaluating the inductance measurement accuracy of the LC meter using inductors of different values. In this video, we've examined the entire design, assembly, and testing process of a DIY LC meter from scratch, step by step. As shown in the tests we just did, this LC meter works great over a broad range and gives us very stable, consistent readings every time. It clearly shows just how important accurate circuit design, the right software algorithm, and a precise calibration process are in practice. If you want to make your own test equipment, get a better grasp of how electronic measurements work, and build something genuinely useful, this project is a great place to start. If you enjoyed the video, please hit that like button, subscribe for similar projects, and let me know what you think in the comments below. I'll see you guys in the next project. Take care.